All right, welcome to The Explainer. We're going to tackle a huge question today. How on earth did the single most important tech company on the entire planet start out in a leaky shack right next to a garbage dump? Yep, you heard that right. Today, we're diving into the absolutely wild origin story of ASML. You know, the company that basically holds the keys to our entire digital world. And I'm not kidding. Their journey literally begins right here, in a leaky shed next to a pile of trash. So to really get how this powerhouse came from, well, that, we have to rewind a bit and talk about its huge parent company, Philips. Back in the 1970s, Philips wasn't just a company. It was a global empire. I mean, this Dutch conglomerate was an absolute behemoth. They were so vertically integrated, they didn't just sell you the light bulb, they built the machines that made the light bulb. A true industrial giant. And get this, at its peak, Philips had over 400,000 employees around the world. To put that in perspective, that's more people than live in a city like Miami. So yeah, this company wasn't just big, it was a genuine global force. And their innovation? It was off the charts. We're talking world-changing stuff here. They invented the cassette tape, helped develop the CD. I mean, Philips was just this constant engine of new ideas. And it was all powered by a secret weapon. That secret weapon? It was called NatLab. This was Philips's legendary research lab. You gotta picture this place. It was like a gold mine for ideas, with 2,000 of the smartest scientists and engineers on the planet all working under one roof. And seriously, remember that name, NatLab, because it is absolutely crucial to where the story goes.
Okay, so what's super interesting here is that this massive empire, and really the entire tech industry, was constantly running a race against one simple, unstoppable force.
And that force is, of course, Moore's Law. This is basically the engine of the entire digital age. The core idea is simple. The number of transistors you can cram onto a chip doubles about every 2 years, making them twice as powerful for the same price. This one little observation kicked off an absolutely relentless arms race to build machines that could print ever smaller, ever more powerful chips. But by the 1970s, the whole industry was about to smack right into a giant brick wall. The problem wasn't a lack of good ideas for new chips. It was the physical process of actually making them. See, the main way they did it back then was called contact printing. And it's pretty much what it sounds like. Think of it like a high-tech rubber stamp. They'd take a glass mask with the chip's blueprint on it and just press it directly onto a silicon wafer. Simple, right? Well, that direct contact had a really fatal flaw. And this right here, this says it all. Every single time that mask touched the wafer, it would leave tiny scratches, dust, you name it. The result? Defect rates as high as 90%. Can you even imagine that? You make 100 of something and you have to throw 90 of them in the trash? It's just insane. So you can see the problem. The process was insanely wasteful, ridiculously expensive, and it just couldn't get precise enough to keep up with Moore's Law. The entire industry was desperate for a new way to do this. So the race was on to find a better way. And the first company to make a major leap forward was an American firm, Perkin-Elmer. What they came up with was something called projection printing. Instead of physically stamping the wafer, they figured out how to use a complex system of mirrors to project an image of the chip pattern onto it. Think of it like a movie projector instead of a rubber stamp. No physical contact. It was a game changer. Yields went up, precision improved, a huge step forward. But here's the crazy part. All the way back in the Netherlands, deep inside Philips's NatLab, their engineers had come up with an even better idea, a far more advanced version of this technology. And it was just sitting there, collecting dust. They had built this prototype called a stepper, and it was totally revolutionary. See, instead of projecting the whole image onto the wafer at once, their machine would focus an intense beam of light on one small square, print it perfectly, and then step to the next square. This allowed for just incredible focus, getting the precision down below 1 micrometer. And just so you know, a human hair is about 70 micrometers thick. This thing was more than twice as accurate as what the competition was doing. So Philips has this world-beating, revolutionary technology just sitting there. They're going to take over the world, right? Well, nope, that is not what happened at all. The problem was, Philips' management was completely distracted. They were busy fighting another war, a brutal battle in the consumer electronics market against Japanese giants like Sony and Toshiba. All their attention was on TVs and VCRs, not some risky experimental chip-making machine. I mean, the irony here is just staggering. The company that literally co-invented the compact disc couldn't see the value in the very technology that would power the entire digital future. And while Philips was hesitating, the rest of the world just moved on without them. An American competitor, GCA, launched the first commercial stepper. Then the Japanese giant Nikon got into the game. And all of a sudden, Philips's brilliant idea wasn't so unique anymore. In fact, some of its design flaws, like using oil hydraulics and not-so-great lenses, were starting to look pretty bad in comparison. Finally, after a lot of pressure from the Dutch government, who really didn't want to see this technology just die on the vine, Philips reluctantly agreed to a last-ditch effort. They spun off the project into this tiny, poorly funded joint venture with another small company called ASM International, and that's how ASML was born. And when I say poorly funded, I mean it. Philips didn't even give them cash. They just gave them a bunch of outdated equipment they had lying around in a warehouse. That's it. Confidence was so low, get this, the first 47 employees demanded a guarantee in their contracts that they could get their old jobs back at Philips if, or really when, this whole thing went belly up. So let's recap. We have a new company with basically no money, a bunch of old equipment, and employees who are so scared they already have an exit plan. So how in the world did this company not just survive, but become the absolute global titan it is today? Well, it turns out its founder, a very clever businessman named Arthur Del Prado, insisted on one tiny clause in that founding deal, a clause that would end up being worth way more than any amount of money or fancy equipment. That clause was their secret weapon, total uninterrupted access to NatLab, that gold mine of Philips research. And that connection gave them the brainpower they needed to fight back, kicking off an insane story of corporate espionage and incredible engineering feats. But that's a story we'll have to save for next time on The Explainer.